Hi Patrick.
Hi Peter.
Hi students. To start our journey into modeling and simulation using the tool Simulink, let us start with a small example. Look at this ball in my hand. When I let it fall down, you all know what's happening. Now let's look at how we can build a model of this process and simulate it. The first step in the modeling process is the development of the model concept. In this step, we select which real-world effects we want to consider in our model and which effects we want to neglect. Then we decide on how to model these effects. Patrick, how would you attempt to do this for our example of the falling ball?
Well, the main feature is of course the ball falling down. Therefore, I would neglect the color of the ball and the material of the ball. And in the first version, I would also neglect the air in the room.
Yeah, okay.
So I will model the system as a point mass accelerated by gravity g. The value I want to calculate is the position of the ball.
Anything else?
Oh, what about the size of the ball?
Perhaps.
What about the mass of the ball?
Well,
if the radius of the ball is too big, it will not fall down as it already touches the ground.
very interesting. Yeah, if the center of mass of the ball is just too low that it will stay on the ground.
Yeah. And what about time frame? Which period of time do we want to simulate?
Of course, we start with me dropping the ball, and we end just before the ball touches the ground. And let's keep the mass in the model for now, although it might turn out that we do not need it.
Okay. When Peter says we stop just before the ball touches the ground, he definitely means we are not interested in the permanent deformation if a beanbag drops on the table, or on the elastic bouncing back of, for example, a table tennis ball.
Okay.
This means we also need the height of the ball and the size of the ball to know at which position to stop the simulation.
Yeah. Okay. Or, on the other hand, we just measure the position of the ball above the ground at the lowest part of the ball.
That's more easy.
Yeah.
We are talking already about coordinate systems and definitions of values. That is already step 2 of the modeling process. In step 2, we describe our system with mathematical equations, building a so-called mathematical model.
Okay.
In our case, we have got Newton's law of motion and Newton's law of gravity.
Exactly. Let us note these equations. The force acting on the ball is the gravity multiplied by the ball's mass. However, the acceleration in turn is the force divided by the mass. This means it is just the gravity g. The ball's velocity is the integral of the acceleration over time, and again the position of the ball is the integral of the velocity over time. What we noted down now is already a mathematical model of our falling ball. Now we have to go to step 3 of the modeling process. Now we have to implement this mathematical model in a simulation tool. For this purpose, we have to choose a tool that is capable of implementing this mathematical model.
Okay. Implementing the model means we use a representation in a tool that permits us to calculate the values within the model that are of interest to us.
Okay.
In our case, the interesting value is the ball's position. Of course, we could use calculus to calculate the ball's position over time, but that's not what this course is all about. We want to use a tool that permits us to simulate the ball's position without explicitly solving the equations given before, but rather doing the integration numerically.
Okay.
Of course, we choose an example in such a way that the simulation tool Simulink provides adequate means to do so.
Yeah, then we can implement this mathematical model in Simulink.
Yeah, and once we employ our implementation of the model to actually calculate output values based on input values and parameters, we call this a simulation or a simulation run. In our example, we have no input signals, but we've got two parameters m and g. Peter, why don't you start Simulink right now so we can see how Simulink is used to implement the model and we can simulate our falling ball as we can calculate its position over time.
Yeah, great. Let's start Simulink. You find it in Matlab, just here to start Simulink. Simulink is a tool that is used to implement mathematical models graphically. For this purpose, it provides a number of so-called building blocks that represent mathematical functions. A mathematical model is implemented by composing a number of such building blocks. The blocks can be found in a library. In Simulink, here you see the library browser that contains all these blocks. And in order to implement the model, the blocks are dragged from the library to the model's workspace. I already prepared a little Simulink file to get started. We open it here and open this model. You will also find this file in the additional materials section.